Kia ora guys, this video is for Cian and it's question 5 from the March 2021 paper. Really good that you're starting to send in questions. Next video coming up will be one for Zico on partial fractions. But this one is a kind of classic A-level question where we have to take a function like this and get it into this form here. So we're going to use the compound angle stuff and Pythagoras for the first bit, and then we're going to solve this equation here using the work we did back in part A. Now this is a slightly harder than usual one, and so I've ended up using general solutions for the second part. Just remember, you won't get the general solutions formula on the formula sheet because it's not taught in the Cambridge syllabus, but it's fine if you want to go ahead and use that. Right, so let's look first at part 1. Well, we've got r sine of x plus alpha, and when we expand that we get r sine x cos alpha plus r cos alpha sine x, and we have to match that up with root 7 sine x plus 2 cos x. So that tells me that root 7 is r cos alpha and 2 is equal to r sine alpha. Now I've done a few other videos doing this, so this is kind of repetitive, but if we just think about our little right angle triangle, well, that was nice. So here's r here, and we've got alpha here, root 7 here, and 2 here. So r by Pythagoras is going to equal the square root of root 7 squared, 7 plus 2 squared, which is 4. So r is going to equal root 11. And what I can do now is solve either this equation or this equation. So what did I do? Well, I did root 11 cosine alpha is equal to root 7. I don't know why I picked that one, it's got more square roots in it, but there you go. So cosine, the angle whose cosine is root 7 over root 11 is equal to 37.09 degrees, and that's to 2dp. I think I was asked that in the question. Yeah, I was told to do it to 2 decimal places. So that's your first 3 marks, right? We've found r and we've found alpha. So let's just write that out nicely. I'm just going to have to pause because the dog has woken up and is barking like crazy. I'll be back in a second. Okay, I'm back. The dog is fine. So let's look at where we've got to. Well, we've done our general expansion, which is here. So we've said that root 7 sine x plus 2 cos x can be written as root 11 sine of what? Sine of x plus 37.09 degrees. Now the reason I'm going slowly and hesitating is because this question is one where you have to read the next bit carefully. This is just the normal thing that we've seen about probably 100 times this year. But this next question says solve the equation blah blah blah, and then we've got 2 theta. Right, so instead of x in the next question we're going to have 2 theta. So some of you, I suspect, didn't read that. So this is what we get next. We get root 7 of sine 2 theta plus 2 cos 2 theta is equal to 1. And using what we just did, we rewrite it as root 11 sine of 2 theta plus 37.09 degrees is equal to 1. And now we've got to solve that. So we've got sine of 2 theta plus 37.09 degrees is equal to 1 on root 11. So the principal value here is this, and this gives me 17.55 degrees. Now I'm looking at this and I'm going, look, this is a double angle, and then I've got a horizontal shift back that way a bit. So I think this is one where I will do general solutions. Often with these, as you know, I will just do them using the graph and symmetry. But we've got to be careful here because we want to end up with all of the solutions that are between 0 and 180 degrees, but we don't want to have any extra ones popping up, and we don't want to miss any out. So the way that I did this one was to go, okay, 2 theta plus 37.09 degrees is going to equal the general solution for sine done in degrees, so 180n plus my flipper times 17.55 degrees. So remember, this came from the symmetry of the sine curve where we're going out 180 and then either in or out. But we did that a long time ago. Okay, so now we have 2 theta is equal to 180 degrees minus 37.09 plus this. And that gives us theta is equal to 90 minus 18.55 degrees plus this. And then I'm going to halve this number. So that gives me 8.77 degrees there. Now, what have I done there? I've done something funny. Okay. Next step, when I get n equals 0, that works out to be too low. That gives me less than 0. And then I substitute n equals 1. And that gives me theta is equal to 90 minus 18.55 minus 8.77. And then when I put in n equals 2, so that works out to be 62.7 degrees. Okay, n equals 2, the flip is going to go the other way. I'm going to get 180 minus 18.55 plus 8.77, which gives me 170.2 degrees. Okay, so that's one way to do it. The other way to do it would be to solve using symmetry here. And just go through more slowly case by case. But I reckon general solutions is the best way for that one. So thanks for watching. Cian, if the general solution stuff is not making sense, let me know and we can jump onto Google Meet and go over it.